Alright, Chapter 1 Summary. This chapter has presented information on waveguide theory with the application of the information that follows to summarize important points of this chapter. Waveguide, a primary method of transporting microwave energy with waveguides that are fewer allow for the greater power handling capability. Transmission line physical side of the waveguides become the too great with a frequency less than 100 megahertz. Waveguides are made of the three basic shapes as shown in the first illustration of the wide A dimension to determine the frequency, the range of waveguide, and B the dimension that determines the power handling capabilities as shown in the second illustration. Waveguide handles a small range frequency both above and below. The primary operation frequency energy transported through the waveguide's interaction electrical magnetic field abbreviated E field and H field, respectively. The density of the electrical field vary the same in the rate of the applied voltage. If the energy that it travels through the waveguide, two boundary conditions must be met. An electric field is as if the surface of the conductor must be perpendicular with the conductor. Very magnetic field must be as if the closed loops parallel to the conductor is perpendicular to the electrical field. Cylindrical, rectangular waveguide A and B wavefronts. The travel down the waveguide reflection from the side of the zigzag pattern after the shown the figure stroke the angle the incident for the same as the right angle of the reflection. It called the reflected wavefront to have the shape of the incident wavefront. The velocity of the wavefront traveling down the waveguide is grouped. The velocity because of the zigzag path of these wavefront. The group velocity is slower than the velocity of the wavefront through the space. Wavefront in the direction of the X, wavefront in the direction of Y. The wall of the waveguide B and C electrical field. The mode of the modes and waveguides are divided into categories: transverse electric mode and transverse magnetic mode. Subscripts are usually complete. The description in the transverse electric and transverse magnetic mode. The dominant mode of the electrical wave guidelines is shown in the figure. Technical transverse electric 1-0 waveguide input schematic that are divided into three basic categories: probes, loops, and slots. Size, shape, and placement of the waveguide are critical factor of the efficiency of the three input of the methods. Wave impedancy matching, if often necessary, reduced through the reflection called the mismatch between the waveguides and load matching devices called the iris is shown in the illustration to introduce either capacitancy, inductancy, or a combination of both into the waveguide. Conductive posts and screws can also be used for impedancy matching in the waveguides. So you have your iris, which is waveguide, the induction coil capacity and the capacity of inductions. Waveguide transmitter prevents standing of the wave end of the waveguide tip. The usually specially constructed horns absorb the loads of the dummy load of the waveguide. Plumberly refer to the bends and twist joints necessary to install the waveguides in the electrical bends. Magnetical bends twist may have the radius greater than 2 wavelengths. The choke joint is shown figure. Most often connect the poop points of the waveguide. The rotation joint is used for the waveguide most connected to the rotating loads such as the antenna. Pressure gasket, and your rotating boat. The direction with the coupler device for the permanent sampling with the energy of the waveguide. Directional coupler may be to construct the sample energy only direction of both directions. Energy remove the direction coupler is smaller than sample is proportional to the magnitude of the energy waveguide. An example of the direction coupler is shown in the illustration. Direction of the propagation waveguide, 1/4 of any direction of the coupler absorbed material to pick up the probe of the output jack. The resonant cavity in each space completely enclosed with the conductive wall that contain the oscillating electromagnetic field that can possess resonant properties. Several cavity shapes that are shown in the illustration. Donut shape, one cylinder, cube cylinder, sheared donut shape. This is cylindrical wall section waveguide. Waveguide junction. There's several basic types of T junction, either with either type of the magnetic type. The effect of the input energy depends on the arm that you put in the junction. And the input of the magnetic type of the junction hybrid is shown with the right combination of the magnetic and electrical type T joints. Ferrite device combined with the mag property, the high resistance for the current flow of the ferrite to construct the compound ferrous metal oxide to achieve the data that are carried with the fight. The fact that the spin axis of the electron wobble the natural resonant frequency of the subject of the external magnetic field of the basic principle of the operation ferrite device. The position ferrite devices within the waveguide is shown in the figure. Steady magnetic field of the ferrite. That was chapter 1 summary.